Alright, Unit 5, the conclusion of quantitative reasoning. So guys, this unit's going to go by pretty quick. There's really only two topics in it, linear modeling and exponential modeling. We're going to kick it off with some linear modeling, and the most important part of linear modeling is slope-intercept form. Now what you're going to realize is Unit 5 is most familiar to content in a standard algebra class. So if you've recently taken an algebra class, you're going to feel right at home for this unit. So we're going to start with linear modeling, and the heart of linear modeling is slope-intercept form, which should sound very familiar to you. Slope-intercept form is y equals mx plus b, where m and b are constants, y and x are variables. So it's very, very, very important for this entire unit that you distinguish constants from variables. Constants are fixed values, they do not change. Variables, well, variables are going to vary. That's what they do. So that's why we represent them with letters. So these constants m and b represent important characteristics of a line. M represents the slope, which is the line's rate of change, and b represents the y-intercept. So slope is the most important characteristic of any line, and slope, which we represent with the letter m, is the line's rate of change, essentially. Every line will have a constant rate of change, and we can view that as rise over run. That's the visual way of looking at it. And the other way of looking at it is y2 minus y1 over x2 minus x1. In other words, that's change in y divided by change in x. So, and a quick little tip here. If you have positive slope, that implies your line is increasing. And if you have negative slope, then that implies your line is decreasing. But then if you have zero slope, then it's a flat horizontal line. Well, we're not too interested in those. So let's look at two quick examples. Let's go ahead and sketch this. So let me draw a quick Cartesian plane. Alright, that will do. So you just want to keep in mind this right here is y-intercept. This value here is the slope. So the y-intercept is where it crosses the y-axis. So our y-intercept is at positive 1. So let's go ahead and mark our y-intercept down. And our slope is 3 over 2, and that's kind of like our rise over run. So getting from point to point, we're going to go up 3 over 2. So starting at the one point we know, which is the y-intercept, we're going to go up 3 over 2. So we're going to go up 1, 2, 3 over 2. Pete, you're fine, bro. We'll eat in a little bit. And connect the dots. And there's our line. So let's do the process in reverse. Write the equation of the line graphed below. So what we need to figure out is the slope and the y-intercept. So we know that the y-intercept right here is at 4, and the slope is down 2 over 1. So that's our equation. We went down 2 over 1, and the y-intercept is 4. So when we simplify that, it's negative 2x plus 4, and there's the equation for that line there. Now, a big part of Unit 5 is being able to write linear equations, provided certain data, and priority uno is slope. So you always want to figure out slope first. Once you have the slope, you can plug in data into the incomplete equation and solve for the y-intercept, and then you can write the linear equation. So let's go ahead and practice here. So basically, anytime you're writing a linear equation, it boils down into two parts. Part 1, figure out the slope. Part 2, figure out the y-intercept. So we mentioned earlier the slope is y2 minus y1 over x2 minus x1, using that slope formula. And we have two coordinates here. So this first coordinate I'm going to call x1, y1, first x coordinate, first y coordinate, and here's my second point at x2, y2. So we just go ahead and apply the formula. So y2 is 1 minus y1 is 5. x2 minus x1 is 7 minus 3. So we end up with negative 4 over 7 minus 3 is 4. So equals negative 1. And we're halfway done. So if we go to write our incomplete equation is y equals negative 1x plus b. It's incomplete because we are missing that b value. So we plug in a point and solve from there. So you can either pick the first point or the second point. I'm going to go with the first point. You do you, boo-boo. Either one will produce the same result. Just make sure to not mix up your x and y values. So we know the y value is 5 when the x value is 3. So I'm going to plug that in. Solves rather quickly. We get Bravo equals 8. And so we know that the slope is negative 1. The y-intercept is positive 8. And there's our equation. Just like that. And when we write the equation, leave the variables as variables. Leave y and x. Y is changing depending upon the x value, and x is changing depending upon the y value. So let the variables vary. The constants are fixed, so those are the numbers we need to figure out. So quick little tip here. Slope represents rate of change for a line, and the y-intercept in many applications represents the initial or base value. So you want to keep that in mind, and let's look at this next example. So here we've got a part-time car salesman. He's paid $1,200 per month plus $350 per car he sells. Write an equation modeling pay. So we know it's a fixed rate. He's going to get the same amount of commission for the first car he sells as he does for the 10th, 12th, 13th car that he sells. So it's a linear equation. So it's y equals mx plus b. And what we need to do is figure out the slope, figure out the y-intercept. So the slope is the rate. So you have to ask yourself, is the rate $1,200 or $350? Well, it's $350 because he's getting $350 per car. And that's in addition to his base salary at $1,200 per month. And it's very, very, very important that you know what the variables represent. So we know in this example, y represents pay, x represents cars sold. If you look at the math there, he's getting $350 per car sold. So that's why it's being multiplied. And then we add 1,200. When we add those two together, we get y, which is his pay. Alright, so if the salesman wants to make $2,500 per month, how many cars must he sell each month? Well, this is where we have to make sure we know what our variables represent. We know the y variable represents his pay, so we set the y value to $2,500, and we solve accordingly. So we'll simply subtract 1,200. So when we do that, that's going to be, grab my calculator real quick. So that's 2,500 minus 1,200, which is 1,300. Then divide both sides by 350. And we get approximately 3.71. So in conclusion, he can't sell 3.7 cars. He can either sell 3 or he can sell 4. 3 is not enough, so that means he needs to be selling at least 4 cars a month to meet that budget value. And what will his pay be if he sells 5 cars? So we got our equation again from part A. Only this time we are not given a y value, we are given a x value. So we set the x value to 5 and compute. So when the x value is 5, then the corresponding y value is $29.50. And that's in dollars. Alright, let's go ahead and wrap up the section with just one more example. And we'll make a quick note here, a little tip. Typically, your y variable is the dependent variable and x variable is the independent variable. If you've ever written a lab report, you're familiar with this when making charts and graphs and such. So if we look at this previous example, going back up here, we can see that y was the dependent variable, which was the salesman paycheck, because that is dependent upon the x variable, which is the number of cars he sells. Alright, so we're going to have to keep that dependent-independent variable in mind when looking at this example. So we got a phone bill that increases linear with data usage. This is pretty typical. If you go over your limit, if you go over your data limit, then there's typically a per gigabyte charge, so that makes it linear. Last month your bill was $73.25 for 7 gigabytes of data, and this month it was $92.25 for 11 gigabytes of data usage. We want to compute the slope. So what we need to do is represent these as data points. And we want to make sure we don't get our x and y values confused. So remember, the y value is the dependent variable. So you need to ask yourself, does the dollar amount depend on the data usage, or does the data usage depend on the dollar amount? Well, of course, the dollar amount depends upon the data usage. So data usage is your x value. The bill cost is your y value. So at 7 gigabytes, the bill is $73.25. And at 11 gigabytes, the bill is $92.25. So there's 4 numbers there, but those 4 numbers really represent 2 data points, right? 7 gigabytes for $73.25, 11 gigabytes for $92.25. And now you can see how to figure out the slope. Now it's just a matter of using that x1, y1 formula. So that's going to be y2 minus y1 over x2 minus x1. So that's going to be $92.25 minus $73.25, all divided by 11 minus 7. So when we compute that, so we get $4.75. And what this is essentially saying, don't forget this part of the problem, interpret the meaning. So it's not just a matter of being able to play with this alphabet soup. I want you to understand and comprehend what it represents. So when you say the slope is 475, that's the rate. Remember, the slope represents rate of change. So you're basically saying it's 475 per gigabyte. That's what we just figured out. It's $4.75 per every 1 gigabyte. And that's a pretty normal rate, at least according to Google. Now let's compute the y-intercept. So if we look at our equation, we have y equals 475, because that's the slope we figured out in part A, plus b. We're missing that, so what we do is go ahead and plug in a point. And I'll go ahead and plug in the first one. So we know the y value is $73.25, and that's when the x value is 7. Make sure to not get your x's and y's mixed up. You'll go ahead and solve that, and when you solve that, you will get, so let's see here, 475 times 7, so 73.25 minus that value, you get 40. And don't forget to interpret its meaning. So typically, your y-intercept represents the initial value, or in other words, it's going to cost $40 is your base bill. Right. If you don't go over your data at all according to this cell phone plan, your cell phone bill is going to be $40. But if you go over your limit, then it's going to be $4.75 for every gigabyte. So if we write the equation, we know the slope is 475 and the y-intercept is 40. And that's an equation that represents cell phone bill right there. So if you want your bill to be below $75, how much data can you use? Well, we set 75 in for the y value and solve for the corresponding x value. So let's go ahead and solve that equation real quick. So that's 35 equals 475. So if your base bill is $40, that means you can afford $35 worth of data, which translates into x is approximately 7.37. So you can afford up to roughly 7.37 gigabytes of data. Alright, and that's a wrap. So guys, I've covered everything you need to finish up the very last worksheet of the semester, and I'll include a helpful YouTube video with more examples. But go ahead, get started on that worksheet, and then it's just one more lecture, one more test review, and we are done with quantitative reasoning. Keep up the hard work.